All right, hello, my name is Evan, and welcome to my MF Bob tutorial. Whenever you're working in Unreal, a lot of times you're going to want to be animating objects, and you can animate them through sequences, but that can be really heavy, and the cheapest and most efficient way to animate objects, whether it's like simple bobbing up and down, rotating, scaling up and down, is going to be world position offset and material functions. So as you can see here in this project, the only two things we have is a material and a material function. If I open this material, you can see that we have a normal opaque material, and we have 3 vector 4 parameters and a texture parameter. And we use these vector 4 parameters to tell this material function, mfbob, what to do with this information. So the 3 values RGB are just going to correlate, as you can see, to XYZ, and that we're using the alpha as a speed variable, okay? And in most versions of Unreal, you can drag the RGBA out from a pin that's supposed to be right here. But in the newest version, 5.6, they took that away for some reason. I think it will get added back in the next one. But for now, I'm just showing that if you're in 5.6, you're going to have to combine all these RGBA together to make a vector 4 and able to plug it in to this material function. And if you don't know what a material function is or how to create it, you can create one by right-clicking your content browser and typing function, and then you can create a material function right here. And basically what we do in a material function is it's going to look pretty similar to your material shader graphs, but the difference is we are taking these nodes and we have input nodes and output nodes, which will correlate to the input and output of our material function. So basically we're using nodes to make a big node that gets condensed into one simple thing that we can fetch. And if you're wondering how to reference these, if you don't, when you first make your material function, this right here, exposed to library, is going to be turned off. And if you have this turned off and you try to search it over here, you're not going to be able to find it. And so the first thing, right when you make your material function, just make sure you turn on exposed to library, apply, and go. And as you can see, we already got, because I just did that, it broke it a little bit, and we are rotating. But for now, we're going to turn off our rotation. We're going to have our move on, and we're going to set our location. We don't want to do it. We're just going to have it go up and down 20 units on the z-axis so you can see what this does for moving. And we're going to be using sine waves. And if you don't know what a sine wave is, a sine wave has amplitude and frequency. And the frequency is how often each of these waves are. Like if there's 1 second between each of these waves, that is the frequency. And the amplitude is how high these waves go up and down. So again, going back to our material function, these x, y, and z are the amplitude, how much we are moving it on that axis, and the speed is going to be our frequency, so how frequent these waves are. So right now, I think each wave is about 1 second because we have our speed down here set to 1. And if you have the speed set to 0, it's not going to work, or it's going to do weird things. I think for moving it, it should be fine. But you'll see later with the rotation, if you don't have your speed set to something above 0, it's going to be really weird. But first off, let's just get into our material function, and so I can show you how this works. So, as you can see, everything in here is very organized. I think it's fine to make material functions and shaders, have it be really messy when you're making it, but if you want to use it in other projects, you're going to want to organize everything. You're going to want to have these named reroutes, and I'll get into those later if you don't know what those are. And you're just going to want to make sure that someone who doesn't know what's going on can actually tell what's going on. So as you can see here, this is all the mfbob material function, and we have our location calculation, rotation, and scale calculations that happen here and get output to these named reroutes. So to make a named reroute, you can right click, type named, and then you type in what you want it to be called. So I'm just going to call this test. And so then when you plug something into this named reroute, this is when it has 2 pins, one on each side, you're setting that named reroute, and then you can fetch it by just typing in its name. And then when it just has an output, that means that you are getting what you set right here. So this is just an easy way to clean up all your shader graphs. I have a tutorial on this if you need to check that out. But yeah, super easy, and it makes your graphs much more professional. So anyways, let's get into what this looks like. So for location, we take our input location, which is that vector 4 parameter that we have in the last one. If you don't know how to make a vector 4, by the way, like over here, you can hold 4 and click, and then you make a vector 4. The same goes with 3, 2, and 1. And then to convert these to a parameter in your material graph, all you gotta do is right click, convert to parameter, and then type in the name. And you can set the default value when you click on it like that. And otherwise you can just, now you can set it in your parameters list for that material. And going back, so we have our input v4, and we're just gonna component mask out. If you search up component mask, you'll bring up one of these, and then you just turn on what channels you want for this specific mask. And so we are separating the RGB, the amplitude, from the frequency. So frequency is speed, and so we need to multiply our time by the speed, and then we plug it into our sine wave. And that's what creates the wave motion that you saw earlier when we were bobbing up and down. But the next thing is we need to tell it how high to bob up and down. So we multiply that by our RGB or XYZ. So that's our amplitude for each axis gets multiplied, and then that gets output into our location WPO node. If you go to our blend chain over here, you can see that we just have a bunch of switch parameters, which will show us Boolean parameters like this: move, rotate, and scale. And we just make sure that if they have move turned off, it's not adding this WPO. And if they have move on, we will add in this world position offset to our previous world position offset. So this input is, if you have any other world position offset stuff going on, you can just plug it into the bottom of the material function. For now, we have nothing on this material, so I just plugged in a vector 3 of 0. And if you want to make sure that the default value is a vector 3 of 0, you can just hold 3, make your vector 3 like that. Let's move these to the side and plug in the default value as that. So now the default value will always be zeros. And so you can see then on our blend chain, the other things we have is we add our rotate in if they have rotate turned on, and then our scale. So you can have all three at the same time, or you can have none of them at the same time. It just depends on what you choose for that material instance. And if you don't know what a material instance is, you take your base material. So this is just a material. You can right click on it, create a material instance, call this MI Bob2. And then what I can show you is two different material instances can have completely different parameters for the rotation that's going on. So let's pull this up. We'll open these, turn on. We're just going to have this one rotate. Then let's set our rotation. And we have amplitude of 2, speed of 0.5. That's pretty fast. So yeah, we're going to keep this at 0.1. That seems like a pretty good value. So now you can see these are moving at, I guess I got to change a little more. Yeah, these are moving and rotating at completely different speeds and have different input parameters. Now we can make it, if we want to make it bob up and down, we can also do that by just going like this, 25. There we go. So going back into our material function though, I'm going to pull up the rotation. And as you can see, when we are bobbing and moving them at the same time, we have some glitch where they're getting really dark. And this is happening because the normals are not being updated, or the vertex normals specifically are not being updated with the mesh when we rotate it using WPO. Okay, so yeah, that normal problem, when we don't have, when you rotate about axis, it doesn't update the vertex normals. And of course, this object is rotating, so the normals should be changing as it rotates. We just need to let the shader know that it is rotating. So what you can either do is have another rotate about axis where you plug in the normals to the position and you have pivot point be 0, or they actually already have a material function made for this called rotate axis about axis normals, fix it. So as you can see, if we just take the normal, the base normals, and it rotates, we get all this artifacts, lighting artifacts and all that. But if we plug everything into the fixed rotate about axis normals, our normals are looking a little bad. There's still some visual glitches. Like if you look at the shadow, you can see that there's some problems, but this is about as good as we're going to get it. And if you're having a lot of problems with your mesh when it comes to this, I just recommend using an unlit shader, because then you won't have any of these problems. But so going into the material function for rotate, basically all we're doing is using this rotate about axis node, and we're using the same time multiplied by speed multiplied by sine. that we used before. This is something that we use in all three of these just to figure out the frequency of the waves. And this time, instead with the amplitude, what we're doing is our rotation is more of a vector that we're rotating the object on. If you don't know about vector math and rotations, that's a whole it's a whole topic that can have a video of its own if you'd like, but otherwise I'm just gonna kind of skip by that today because it's advanced vector math. But basically, we want to take whatever was plugged into the vector 4 and we normalize it. It takes the values, if they're too big, they're going to get smaller, and if they're too small, they're going to get bigger, and it's going to make a unit vector. So a vector of length 1, and that is our normalized rotation axis, so the axis that we are rotating the object on. And then we have our rotation angle, which is our time multiplied by sine. Our pivot point is just going to be the object pivot point, and our position is just absolute world position. This is the default, and these two are the default anyways with this. You don't have to plug them in, but the other ones you have to. And so now we have our rotation happening, and yeah, as you can see, it works pretty well if you change the parameter values. Like if we go into mbob, we can change these rotations to something like 0.2, 0. Now it's really only rotate on the Z and a little bit on the X. And you can just get a lot of different cool animations for this, for like pickups, little objects in the store or something. If you just want to give life to an object in your scene, this is good. And then the last function that we're going to get into is the scaling. So the scaling is it looks pretty simple, but it is more complicated than the other ones at its core and messes with these a lot. Again, with the normals, I don't know how to change the normals based on scale. If you have any idea, please put in the comments. But basically the scale one, what we do is what WPO does, world position offset, is it takes each vector in the mesh and offsets it by your WPO that you're plugging in. And so for scale, to make an object bigger, we're finding the distance between the object pivot point and the object, the place where your ray is hitting. So the pixel that your camera is looking at, where it is on the mesh, we find the distance from the pivot point. And then the way that you scale an object up is you multiply that by our amplitude that we have right here. And we have to subtract 1 from our amplitude because, again, this is world position offset. So you need to make sure that your values that you're plugging in are offset, not just setting the scale of the mesh. So we subtract 1 for that. And then again, what we just do is multiply by our time, multiply by our frequency, and then plugged into sine. So then we have our time multiplied by amplitude, and then we are splitting these vertex apart and pushing them away from the pivot point. We're just making sure the distance between the absolute world position and the pivot point is larger or smaller if you're shrinking the object. So going back in here, if we turn off move, rotate, and just turn on scale real quick. I'm going to delete this second one so it's out of the way. What's our scale looking like? Yeah, so when all the values are set to 0 in scale, it looks kind of weird. But if we set them all like this, yeah, you can really get the same sort of like sine animation that we had before. So 111 is just going to set the scale to 1, so it's not really going to do anything. So you're going to want to set them all to a universal value. So this will go from, looks like scale 0 to scale 2, so you can scale up and down. And of course, it looks a little fast, so you might want to slow it down. And I think if you want it to only animate a little bit, you can make the numbers smaller, like this. And so here you can see it's really only going down to 0.2 and then popping back out. So that one's more useful than it going to 0. Yeah, so as you can see, the shadows are messed up. The normals kind of get messed up sometimes. So I would mostly just use scale on its own or very subtly. But otherwise, move and rotate work together on their own combined, like this. And so yeah, now you have a way to really animate any objects in your scene super easily. Let's say that you want to make a wheel, right? You got a wheel on a car that you want to rotate, but you don't want to animate it through sequencer or through a skeletal mesh. You can take your material. Let's put the Bob 2 on this one. Let's make it a cylinder. Then we're gonna rotate that cylinder like this and go into Bob 2 material, rotate on, move off, and let's see, not that axis, we want it like this. So there we go. And as you can see with this, so our sine wave isn't really going to work with a wheel because wheels don't really go back and forth like this. So if you are making non-sine wave animations with the rotation, what we can do is we'll go in here and we'll add this real quick. So we have our rotate static switch. We have our rotate static switch parameter, and now we're going to make another one. Let's call it rotate linear. So what this means is that we're not going to multiply time by sine wave anymore. We're just going to keep going up multiplied by our speed. So it's not going to go back and forth. It's just going to keep rotating. So to set this up, let's organize first. Organization is very important. And the thing that's going to be different that we're going to need to change is the rotation angle. So we can put this next to rotation angle. Let's organize these a little more. Put these down here. Put this one down here. So we can put this right there. Rotation angle. So if rotate linear is false, which is the sine wave, it should be this one. And then we need what is going to be true. We can just get rid of the sine wave, plug it in like that. Default value, let's have this on default false. And you can also put this in your moving one if you want, but it will just keep going. Like if the sine wave keeps the location in the same spot, but rotation, if it gets past 360, it's in the same spot. It's just going to keep rotating. If you get rid of the sign on the movement or the scale, it will just keep going in one direction and it will be off your screen before you know it. So the linear is really only usable in the rotation. So again, we made this new static switch parameter. Let's go back in here. Let's look at our wheel, Bob 2, and turn on rotate linear. And as you can see, it's not a sine wave anymore. It's just going in one direction. So we can go back in here. We want it to be faster. There we go. We got a nice wheel spinning. Yeah, that's it. So you can buy this project file on my Patreon for $5. Or you can be a member on my Patreon and get all the project files. And I'd like to give a shout out to Epic Games for this video. This is part of, I received an Epic Mega Grant for my map Infinite Highway, and I'm making these tutorials building up to show how I made that map. We're going to get into procedural generation, we're going to get into all sorts of shader stuff, skyboxes and all that. And yeah, just a huge shout out to Epic Games for basically making it possible for me to make these videos as my job now. Now I have some funding so I can make them higher quality. So if you have any suggestions for videos or any feedback, please let me know and I'll put it in the next one. All right, thank you. Have a good one.